Hello everyone. Welcome to the lecture on circuit switching versus packet switching, which is one of the most important topics in the field of computer networks. Before we begin discussing the technical aspects of this topic, let us first think about how communication takes place in our everyday life when we use digital devices. Every day we use technologies like phone calls, messaging applications, email, video streaming, web browsing. All of these activities involve sending data from one device to another across a network. However, an important question arises. How does this data actually travel across a network from the sender to the receiver? This is where the concept of switching occurs. Switching refers to the process of selecting a path through which data travels from the source device to the destination device across a network of interconnected devices. To make this concept clearer, let us consider a simple example. Imagine you're making a traditional telephone call to a friend. When you dial the phone number, the telephone network establishes a dedicated communication path between your phone and the receiver's phone. Once this connection is established, the conversation can begin. This method of communication is known as circuit switching. Now let us think about another example. Suppose you send a message through WhatsApp or load a web page using your browser. In this case, the data does not travel through a single reserved communication line. Instead, the data is divided into small pieces and transmitted through different routes across the internet. This method of communication is called packet switching. In this lecture, we will explore these two switching techniques in detail. First, we will understand what switching means in computer networks. Then, we will study the concept of circuit switching and how it works. After that, we will examine packet switching, which forms the foundation of modern internet communication. Finally, we will compare both the techniques and discuss their advantages, disadvantages, and application. Now that we have introduced the topic with some real life examples, let us begin by understanding the concept of switching in computer networks. In computer networks, switching refers to the process of forwarding data from one device to another through intermediate networking devices. In most communication systems, the sender and receiver are not directly connected. Instead, they communicate through multiple intermediate devices such as routers, switches, bridges, and gateways. For example, when you open a website on your laptop, the request from a computer does not go directly to the web server hosting that website. Instead, the request travels through several routers and network links before reaching the destination server. Each router along the path must decide where the data should be sent next in order to reach the correct destination. This process of determining the path and forwarding data is known as switching. Switching mechanisms create communication pathways that guide the movement of data through the network. These pathways may be two dedicated pathways where a specific route is reserved before communication begins, dynamic pathways where the route may change depending on the network traffic conditions. The switching technique used in the network has a significant impact on several performance factors such as network efficiency, transmission speed, bandwidth utilization, scalability of the network, reliability of the network, and reliability of the communication. In this diagram, if you observe this very clearly, we can see multiple computers connected through networking devices such as routers and switches. When computer sends data, the information passes through these intermediate devices before reaching the destination computer. In large-scale networks, like the internet, this process occurs continuously, allowing millions of devices to communicate with each other efficiently. Now that we understand the concept of switching, let us move on to the first technique known as circuit switching. Circuit switching is a communication model in which a dedicated communication path is established between the sender and the receiver before the communication begins, before any data can be transmitted. In simple terms, this means that the network creates a continuous communication circuit connecting the two devices. Once this circuit is established, all data transmitted between the sender and receiver travels through the same route for the entire duration of the communication session. There are three main characteristics of circuit switching. First one is the dedicated path. This means that the network reserves a specific communication channel exclusively for the communicating devices. Second characteristic is fixed route. All the data follows the same path from the sender to the receiver throughout the communication session. The third characteristic is that the circuit switching is connection oriented. This means that before any data transmission can occur, a connection must first be established between the sender and receiver. A common real world example of circuit switching is our traditional telephone system. When you dial a phone number, the telephone exchange establishes a dedicated line connecting the two telephones. During the entire phone call, that communication line remains active even if the users are not speaking continuously, ensuring consistent transmission characteristics. To understand circuit switching more clearly, let us examine how it operates inside a network. Circuit switching communication occurs in three main phases. Setup phase, in which the network establishes a communication path between the sender and receiver. The network identifies a route through intermediate switches and reserves the necessary resources along that route. No data is transmitted during this phase. Then is a data transfer phase. Once the circuit has been established, the communication enters the data transfer phase. Since the communication path has already been reserved, data can flow continuously between the sender and receiver. Third is a termination phase. Once the communication session is completed, the connection is terminated and the reserved resources are released. So, this way it shows and ensures stable communication, but may also result in inefficient use of our network resources. Now, features of circuit switching. Let us look at some important features of circuit switching. The first feature is the dedicated communication path. This ensures that the communication channel is exclusively available for the two communicating devices, like this. The second feature is constant bandwidth. Because the communication path is reserved beforehand, the transmission rate remains stable regardless of the network congestion. The third feature is low delay after setup. Once the circuit has been established, the data transmission occurs smoothly with minimal delay. However, circuit switching has certain limitations. If the user stops transmitting the data temporarily, the communication channel remains reserved even though no information is being transmitted. For the traditional telephone systems, primary application is in PSTN, which is Public Switch Telephone Network Infrastructure. To overcome all the limitations of circuit switching, a more efficient communication technique called packet switching was developed. In packet switching, data is divided into several small units called packets before being transmitted through the network. Each packet contains both the actual data and control information such as the source address and destination address. Packets travel independently through the network. Different packets belonging to the same message may travel through different routes depending on the network conditions. And once all the packets reach their destination, they are reassembled in the correct order to reconstruct the original message. Packet switching allows multiple users to share the same network infrastructure efficiently. This innovation played a crucial role in the development of the modern Internet. This approach also maximizes network efficiency by allowing multiple communication to share the same infrastructure dynamically. Then we have packet switching operation. The operation of packet switching can be explained through four main steps: segmentation, independent routing, store and forward, and reassembly. For segmentation, the original message is divided into several smaller packets. Breaking fast data into smaller packets makes transmission more manageable and efficient. Each packet carries a portion of the original message along with control information such as the addressing information. In independent routing, each packet travels independently through the network. Unlike circuit switching, packets do not have to follow the same route. Instead, routers determine the most efficient path for each packet depending on the network traffic and congestion conditions. Store and forward. When a packet arrives at a router, the router temporarily stores the packet, analyzes its destination address, and then forwards it to the next router along the path. This process continues until the packet eventually reaches its destination. Reassembly. Once all packets arrive at the destination, the receiving device rearranges them in the correct order using sequence numbers. After that, the original message is reconstructed. If we observe the diagram on this slide, we can clearly see how packets move through several routers before reaching the destination device. Some packets may take one router, while other packets may take a completely different route. Eventually, they all arrive at the destination and are reassembled to recreate the original data. Circuit switching versus packet switching key differences. Now that we have studied circuit switching and packet switching individually, let us compare these two techniques to understand the differences more clearly. The first major difference is the type of connection used. In circuit switching, a dedicated communication path must be established between the sender and the receiver before any data can be transmitted. This means that the network reserves a specific communication channel for the entire duration of the session. In contrast, packet switching does not require a dedicated connection. Instead, data is divided into packets, and each packet can travel independently through the network. Second difference is the path usage. In circuit switching, once the path is established, the same route is used for the entire communication session, which means path remains fixed until the connection is terminated. However, in packet switching, packets can travel through different routes depending on network conditions. Routers dynamically determine the best path for each packet based on network congestion and routing algorithms. The third difference is resource allocation. In circuit switching, network resources such as bandwidth are reserved before communication begins, which ensures predictable performance but may result in inefficient resource utilization. In packet switching, resources are shared dynamically among multiple users, which allows the network to support a much larger number of simultaneous communications. Another important factor is efficiency. Circuit switching generally has lower efficiency because the communication channel remains reserved even when the data is being transmitted, even when no data is being transmitted. But packet switching is more efficient because multiple users can share the same network infrastructure. This is why, in terms of efficiency, circuit switching has lower utilization, whereas packet switching has higher utilization. Now, let us consider examples. Circuit switching generally has lower efficiency because the communication channel remains reserved even when no data is being transmitted, whereas packet switching leads to higher utilization. Circuit switching was primarily used in traditional telephone networks where stable and continuous connection was required. Packet switching is used in modern networks including the internet, local area networks, and mobile communication systems. Another difference is bandwidth usage. Circuit switching provides a guaranteed bandwidth because the path is reserved and it is used in advance. Packet switching provides variable bandwidth depending on network traffic. Finally, we can compare the delay trans characteristics. In circuit switching, there is a setup delay while the connection is being established. However, once the connection is established, the transmission, the communication happens smoothly and the transmission delay becomes very low. In packet switching, there is no connection setup delay, but packets may experience processing delays and queuing delays as they pass through routers. Understanding these differences helps us determine which switching technique is more suitable for different types of communication systems. The advantages and disadvantages of both switching techniques. Understanding the strengths and limitations of each method helps us appreciate why packet switching eventually became the dominant technology in modern networking. Advantages of circuit switching. One major advantage of circuit switching is predictable performance. Because the communication path is reserved before transmission begins, the quality of communication remains stable throughout the session. Another advantage is guaranteed bandwidth. Since the communication channel is dedicated to a single pair of users, the available bandwidth remains constant and is not affected by other users on the network. Circuit switching also provides low transmission delay after the connection is established. Once the circuit is created, data can flow continuously without interruption. Another benefit is that circuit switching typically does not experience packet loss during transmission since the communication path is dedicated and controlled. So there's absolutely no packet loss. Disadvantages. Despite these advantages, circuit switching also has some several drawbacks. One of the major disadvantage is resource wastage during idle periods. Even when no data is being transmitted, the communication channel remains reserved, preventing other users from utilizing that bandwidth. Another disadvantage is expensive infrastructure. Maintaining a dedicated communication path requires significant network resources. Circuit switching also requires some setup time before communication begins. Additionally, circuit switching is not suitable for bursty data traffic, where data is transmitted intermittently rather than continuously. Some advantages of packet switching. Packet switching offers several advantages that makes it ideal for modern communication systems. The first advantage is efficient resource utilization. Since network resources are shared dynamically among multiple users, the network can support many simultaneous communications. Another advantage is that packet switching does not require a dedicated path, which simplifies communication. Packet switching also supports multiple connections at the same time, allowing large networks like the internet to handle millions of users simultaneously. It is also particularly effective for bursty traffic, where data is transmitted in regular intervals. Disadvantages of packet switching. However, packet switching also has some limitations, as we can see. Because packets may travel through different routes, there may be variable delays in packet delivery. Packet switching networks may also experience potential packet loss, especially when the network becomes congested. Another challenge is the overhead associated with packet headers. Since each packet must carry control information, finally, packet switching requires complex routing mechanisms to determine the best path for each packet. Finally, let us discuss the applications of circuit switching and packet switching and summarize the key points from this lecture. First, we discuss the applications. Circuit switching was widely used in traditional telephone networks, also known as the public switched telephone network (PSTN). It was also used in the Integrated Services Digital Network or ISDN, which provides digital communication services. Another application of circuit switching includes dedicated leased communication lines, where organizations require a permanent and stable communication channel. Although circuit switching is less common today, it is still used in some specialized communication systems that require guaranteed bandwidth and stable connections. Application of packet switching. It is widely used in modern communication systems. Most important example is the internet communication, which relies entirely on packet switching to transmit data across global networks. It is also used in local area networks and wide area networks, enabling computers to communicate efficiently. Other applications include email services, web browsing, video streaming platforms, and voice over IP communication systems. Modern mobile communication networks, such as 4G and 5G networks, also rely heavily on packet switching to transmit data. Modern significance. Packet switching has become the dominant technology in networking because it provides superior efficiency, scalability, and flexibility. By allowing multiple users to share the same network resources dynamically, packet switching enables large scale communication systems like the Internet to function effectively. To summarize, circuit switching establishes a dedicated communication path before data transmission begins, ensuring stable and predictable communication. Packet switching divides data into smaller packets that travel independently through the network, allowing efficient resources and sharing of these resources and scalable communication. While circuit switching played a significant role in early communication systems, packet switching has become the backbone of modern digital communication technologies. Understanding these two switching techniques is essential for anyone studying computer networks because they form the foundation of how data communication systems operate today. I hope you enjoyed the lecture. Thank you.